Imagine standing in an office, right? You're in a high-res building, you're looking out the window, and suddenly this massive flash of light hits the side of your building.
A light that is literally hotter than the center of the sun.
Exactly. And in an instant, the paint on your walls just vaporizes. The wood of your desk spontaneously combusts, the curtains ignite, and then
Nothing. Yeah.
nothing. For 10 agonizing seconds, you are just sitting in a burning room. You're waiting in this absolute deafening silence for a supersonic wall of crushed air to arrive and just tear the building down. Today, we are looking at the terrifying physics of that 10-second gap.
Yeah, it's the gap between the speed of light and the speed of a shockwave. And unfortunately, that 10-second window is really just the prologue to a cascade of elemental chaos. Stuff that fundamentally breaks our modern understanding of warfare.
So welcome to today's deep dive. We are unpacking an incredibly dense, highly technical, and honestly deeply unsettling interview today.
Very unsettling, yeah.
And it features Theodore Postol. For those of you who track this space, you know Postol is an absolute heavyweight. I mean, he's an MIT professor of science, technology, and national security policy.
Right, he's a former Pentagon advisor. He is basically the person you call when you need to understand the granular, molecular level reality of nuclear weapons and delivery systems.
So the source material we're dissecting today is a recent interview he gave on the YouTube channel Glenn Deason. And we really need to establish the premise immediately here.
Yeah, because Postal is operating on a very specific manufactured timeline in this interview. He conducts his entire analysis as if we are living in the immediate aftermath of a hypothetical June 2025 surprise conventional attack.
Right. An attack by the United States and Israel on Iranian soil.
Exactly. And he uses that imagined scenario to meticulously detail exactly how Iran could, and in his view, inevitably would retaliate with nuclear force.
But before we get into the physics of, centrifuges and firestorms, we have to frame how we are approaching this. Operating strictly within Postol's paradigm means we're navigating some highly charged geopolitical terrain here.
Oh, absolutely.
Throughout this interview, he assigns massive, explicit blame to specific U.S. administrations. He names both Trump and Biden, as well as Israeli leadership.
Right. He argues that decades of diplomatic malpractice and aggressive posturing have cornered a sovereign nation. And in his view, that makes this catastrophic retaliation a mathematical certainty.
Which is a heavy claim.
It is. And to understand his grim conclusion, we have to look at the geopolitical dominoes he believes have already fallen. So just a quick disclaimer for you listening. We are here to dissect the anatomy of his argument, right? To unpack the science he leverages and explain his strategic logic.
Yeah, we are absolutely not endorsing his political viewpoints or validating his worldview.
No, not at all.
We are strictly acting as your impartial guides through the architecture of his warning. Because the science he presents is, well, it's something everyone should understand.
Right. So we have this hypothetical strike on Iran. And Postol's entire thesis hinges on the idea that Iran wouldn't need years or even months to retaliate with a nuclear weapon.
Which goes against what a lot of people assume, right? Like, they don't need a finished, tested bomb sitting in a silo somewhere because they are what is known as a nuclear threshold state.
Yeah, and that phrase, threshold state, it fundamentally alters the calculus of deterrence. Like, back in the mid-20th century, intelligence agencies relied on these massive lead times.
Building a nuclear program required immense, sprawling industrial complexes. You needed years of mining, endless testing.
Exactly. You had a really long runway to intervene diplomatically or militarily if you needed to, but a threshold state has already run like 99% of that marathon.
They have all the pieces.
They have the technological pieces, the raw materials, the scientific infrastructure. They've just made a political choice to pause right before final assembly.
Okay, let's unpack this. It's kind of like having a fully stocked kitchen, right? You've mixed the batter, the oven is preheated, you don't have a baked cake yet, but turning that batter into a cake is going to happen very fast once you put it in the oven.
That's a great analogy. And let's look at the raw materials Postol points to, the batter, in this scenario. He states that Iran currently possesses roughly 408 kilograms of 60% enriched uranium hexafluoride, or UF6.
Okay, 408 kilograms. To understand why that specific number is so terrifying, we have to look at the physics of enrichment, because natural uranium, just the stuff you pull out of the earth, is almost entirely an isotope called uranium-238.
Right, which is heavy, stable, and completely useless for a bomb.
Completely useless. What you actually need is uranium-235, which makes up less than 1% of natural uranium ore.
So enrichment is essentially this brutal, incredibly energy-intensive process of filtering out all the useless U-238 just to concentrate the U-235.
And for context, civilian nuclear reactors generally run on uranium enriched to, what, about 3 to 5%?
Yeah, exactly. But to build a reliable, compact nuclear weapon, you need weapons-grade material. And that is universally considered to be 90% enriched or higher.
Okay, so they have 60% enriched material, which to a layperson sounds like they are only 2/3 of the way there. Like they still have a long way to go.
But that's the trap. The physics of enrichment is wildly nonlinear. The metric they use to measure the effort required to enrich uranium is called a separative work unit, or SWU.
SWU math. This is the key to this entire geopolitical crisis, isn't it?
It really is.
Yeah.
Going from natural 0.7% uranium up to 5% civilian-grade material requires massive amounts of energy and time. It actually constitutes roughly 70 to 80% of the total effort required to reach weapons grade.
Wow.
Yeah, because you are sifting through literal mountains of useless isotopes to find the rare ones. But once you reach 60%, you've already removed the vast, vast majority of the U-238.
So taking that 60% material and pushing it to 90%.
It requires a tiny fraction of the original effort. It's no longer a marathon. It is a very, very fast sprint.
To use a mechanical analogy here, think of a massive, heavy-duty coil spring. For the last decade, Iran has been slowly, methodically turning the crank, winding tension into that metal. Going from natural uranium to 60% is winding that spring until it is screaming with stored energy.
Right.
They haven't released the catch yet, they haven't assembled the bomb, but the energy is already there. So a preemptive strike wouldn't be stopping them from winding the spring. It might simply be the impact that snaps the catch.
And Postol visualizes this stored energy in a really stark way. He describes this 408-kilogram stockpile of 60% enriched UF6 as being stored in rugged, highly durable canisters.
We're not talking about massive underground vats here.
No, these are cylinders about a meter long. They weigh about 50 kilograms total, and they contain roughly 25 to 30 kilograms of the material each. And Postol calculates that this specific stockpile provides enough raw material for 10 to 11 nuclear weapons.
10 to 11 warheads just sitting dormant in meter-long tubes.
Yeah. And the physical state of this material is fascinating too, because at normal room temperature, uranium hexafluoride isn't like a glowing green liquid out of a comic book.
Right. Postol notes that if you looked at it in a clear glass container, it would actually look like a solid, crystalline substance.
But the danger unlocks with a very slight change in temperature. If you heat that canister to just 40 or 50 degrees Celsius.
Which is around 100 to 120 degrees Fahrenheit. Right. Barely hotter than a summer day in Phoenix.
Exactly. At that temperature, that solid crystal skips the liquid phase entirely. It sublimes directly into a thin, clear gas.
And you need it as a gas to feed it into the centrifuges. You obviously can't enrich a solid block of crystal.
Precisely. You feed this hot UF6 gas into a cascade. Now, a centrifuge is essentially a tall, incredibly precise cylinder spinning at supersonic speeds.
Which creates immense centrifugal force.
Right, so on a molecular level, the slightly heavier gas molecules, the ones containing the useless uranium-238, are pushed outward against the wall of the spinning cylinder.
Leaving the slightly lighter molecules, the uranium-235, to concentrate closer to the center axis.
Yeah, then you skim that lighter gas from the center, pipe it into the next centrifuge, spin it, skim it, and repeat. That interconnected chain is what we call a cascade.
And Postol specifically references a known Iranian cascade consisting of 174 advanced centrifuges.
And here's the kicker. Because they are feeding 60% enriched gas into this cascade, reaching the 90% weapons-grade threshold takes practically no time.
How much time are we talking about?
Postol estimates a few weeks, maximum. And if they are running multiple cascades in parallel inside their subterranean facilities, that timeline shrinks to days.
Days. So we have a weapon that can be finalized in a matter of weeks or days, completely bypassing the years of early warning detection that intelligence agencies rely on.
Yeah. It fundamentally breaks the traditional geopolitical safety net. If you can't see the bomb being built over years, diplomacy is really your only radar.
Which brings us to Postol's absolutely scathing critique of how that radar has been intentionally smashed. Because he built his entire retaliation scenario on the premise that diplomatic guardrails have utterly collapsed, leaving deterrence as literally the only remaining language.
And he lays the blame for this collapse squarely at the feet of U.S. and Israeli policymakers. He focuses really heavily on the death of the JCPOA.
The Joint Comprehensive Plan of Action, better known as the Iran nuclear deal.
Right. The mechanics of the JCPOA were specifically designed to manage the breakout time. Breakout time being the time it would take Iran to enrich enough uranium for a single bomb.
By strictly capping their enrichment levels at around 3.67% and dismantling thousands of their advanced centrifuges.
Exactly. The deal artificially extended that breakout time to roughly 1 year. It provided the international community with a 12-month buffer to detect and respond to any sprint toward a weapon.
But Postal acknowledges that President Donald Trump was the one who unilaterally pulled the United States out of the agreement, which shattered that 12-month buffer.
Right. But what is really striking here is his intense focus on the Biden administration's handling of the aftermath.
Yeah, he directs a massive amount of vitriol at current national security advisors. He explicitly names Jake Sullivan, calling their approach disastrous.
His core grievance really centers on diplomatic malpractice during the transition of power. Postal argues that when Biden took office, the logical move to restore international stability was to immediately re-enter the treaty the U.S. had broken. Assuming Iran returned to compliance, of course.
But instead, according to Postal, the administration's advisors fell victim to hubris. They tried to use the leverage of the broken treaty and the crushing economic sanctions that came with it to extract further concessions from Iran before rejoining.
Yeah, they wanted a longer and stronger deal.
Right.
But in Postal's view of statecraft, you cannot unilaterally break an agreement, watch the other party suffer immense economic damage, and then demand a higher price when you finally decide to sit back down at the negotiating table.
It's a profound miscalculation in his eyes. He says it destroyed any remaining institutional trust. It pushed Iran to abandon their own compliance, rebuild their cascades, and aggressively stockpile the 60% enriched uranium we just talked about.
He basically assigns the current administration a massive share of the negative credit for creating the very threshold state they were trying to prevent.
And he also argues that the geopolitical bedrock supporting a preemptive strike against Iran is crumbling anyway. He claims the U.S. public is exhausted by endless Middle Eastern conflicts and is simply fed up with Israel's aggressive military posture.
Yeah, he makes the pointed assertion that American citizens, and he includes deep factions within the American Jewish community in this, will absolutely not allow themselves to be sucked into a massive regional war to defend Israel against an Iranian retaliation.
You pair that with his claim that the Israeli economy is in shambles, and he paints this picture of an aggressor lacking the internal resilience and external backing to survive the war they are starting.
Right.
But wait, I have to challenge the premise here for a second. Postal is assuming that in the event of an attack, Iran wouldn't just retaliate against military targets, right? He assumes they would intentionally target a civilian center like Tel Aviv to cause a firestorm.
Yes, he does.
Does that actually align with Iran's stated military doctrine, or is he just engineering the absolute worst-case physical scenario simply to make a point about deterrence?
It's a crucial question to ask, and Postol is absolutely engineering the worst-case scenario. But he roots it in his interpretation of modern statecraft. He references diplomatic rules established since the era of Ivan the Terrible.
Ivan the Terrible, okay.
Right. He argues that basic rationality in international relations relies on the belief that treaties will be honored and adversaries will act with some degree of restraint. Postol believes that from Iran's perspective, the U.S. and Israel have totally abandoned that restraint.
So if a nation believes its adversary is acting irrationally and poses an existential threat to its survival, proportionality just goes out the window.
Exactly. If trust is dead, absolute terrifying deterrence is literally the only tool left to guarantee survival.
Okay, let's step out of the geopolitical arena for a bit and go back into the subterranean tunnels. Because Postal's timeline dictates that diplomacy has failed, the strike has happened, and the Ayatollah has given the order to assemble the weapons.
The spring has snapped.
The spring has snapped. We left off with 90% enriched UF6 gas coming out of the centrifuges. But, you can't drop a cloud of toxic gas on Tel Aviv and expect a nuclear yield. How does a hot gas become a functional, solid weapon?
This is where Postol dives into the gritty industrial chemistry of weaponization. And what is most alarming is the footprint required to do this. He essentially outlines a process for building a garage bomb.
The garage bomb.
Yeah. We are moving from the high physics realm of isotopic separation into basic metallurgy, which he argues can be done in a space the size of a large closet.
So the first step is chemical conversion. You have to turn that 90% enriched gas into solid uranium metal.
Right. You start by blowing high-temperature hydrogen fluoride gas through the UF6 inside a specialized reaction chamber.
Now, hydrogen fluoride is incredibly toxic and corrosive.
Extremely. So you need specialized baffles and vacuum seals. But the physical equipment itself is actually small. It requires feet of space, not acres.
And the chemical reaction between these two hot gases produces tiny, heavy green particles of a new substance, uranium tetrafluoride, or UF4.
So to separate this green dust from the toxic gas stream, you use a standard industrial tool called a cyclone separator.
How does that work?
It essentially creates a high-speed vortex of air inside a cone. The heavier green UF4 particles are thrown against the walls of the cone by centrifugal force, and they just fall to the bottom, while the lighter gas is vented out the top.
Okay, so now sitting at the bottom of the cyclone, you have a pile of highly enriched green dust. Still not a bomb.
Not yet. The next phase is precipitation, which is essentially a violent thermite-like reduction reaction. You take those green UF4 particles and mix them with a reducing agent. Postol mentions calcium or lithium.
Right.
And you place this mixture inside a high-pressure, heat-resistant vessel called a bomb reduction reactor.
Which Postol points out is small enough to literally sit on a standard office desk.
Desk-sized.
Yeah.
You heat the sealed vessel, triggering a violent chemical reaction. The calcium or lithium strips the fluorine atoms away from the uranium.
Yeah.
And because pure uranium metal is incredibly dense-like, almost twice as dense as lead, it melts and sinks to the bottom of the vessel under the immense heat and pressure.
While the lighter byproducts just float to the top as slag.
Exactly. When the vessel cools, you literally break it open, chip away the slag, and you are left with a solid, heavy ingot of 90% enriched, weapons-grade uranium metal.
We've gone from a crystal to a hot gas to green dust to a solid metal ingot sitting on a desk. And Postol asserts this entire chemical conversion requires maybe a few hundred square meters of floor space.
Yeah?
You don't need a sprawling industrial complex visible to satellites. You just need a reinforced room in a tunnel somewhere.
And once you have the ingots, you face the final hurdle, machining and assembly. And Postol describes a very specific, historically proven architecture here known as a gun-type assembly.
The mechanics of this are terrifyingly straightforward, honestly. You machine the uranium into two distinct shapes. First, a hollow sphere, or cylinder with a large hole through the center. Second, you machine solid plugs of uranium designed to perfectly fill that void.
Right.
You place the hollow sphere at one end of a strong metal tube, literally a gun barrel. You place the solid plugs at the other end, and behind the plugs you pack standard, conventional high explosives.
Because the goal is to achieve critical mass. A single piece of uranium, if it's below a certain weight and density, will just sit there emitting mild radiation. It won't explode.
Right.
But if you force enough of it together fast enough, the neutrons naturally decaying from the atoms will start hitting other atoms, splitting them, and releasing more neutrons in an exponentially growing chain reaction.
So when you fire the conventional explosives, they propel the heavy uranium plugs down the barrel at immense speed, slamming them into the hollow sphere.
And at the exact millisecond of impact, an initiator is triggered to guarantee the chain reaction starts violently. Postol mentions a beryllium and plutonium initiator.
Let's actually explain how that works, because it's a fascinating piece of atomic engineering.
It is. So inside the bomb, you have a tiny pellet of plutonium and a piece of beryllium, kept separated by a thin membrane. Plutonium naturally emits alpha particles. When the uranium pieces slam together, the impact crushes the membrane, forcing the plutonium and beryllium together.
And the alpha particles from the plutonium strike the beryllium atoms, which instantly knocks a massive shower of loose neutrons out of the beryllium.
Right. This flood of neutrons injects into the newly formed critical mass of uranium, guaranteeing a catastrophic runaway nuclear chain reaction before the physical physics of the collision can bounce the metal apart.
And Postol estimates this brute force design would yield an explosion of roughly 15 kilotons.
Wow.
Which brings me to my biggest point of pushback on his entire scenario. Postol claims with absolute, unwavering certainty that Iranian scientists would not even need to test this weapon before loading it onto a ballistic missile and firing it at a city.
That sounds crazy, right?
Yeah.
Like, can you really cobble together an untested nuclear weapon in a subterranean closet and trust it to detonate with 100% confidence?
It totally defies our modern engineering intuition. I mean, today we simulate and field test literally everything ad nauseum. But Postol's confidence is rooted deeply in the history of the Manhattan Project. He is pointing directly at the little boy bomb dropped on Hiroshima.
Right, because the famous Trinity test in the New Mexico desert, the one with Oppenheimer and the massive steel tower, That wasn't a test of this gun-type design at all. Exactly. The Trinity test was proving the concept of a vastly more complex implosion design using plutonium, which required perfectly timed explosive lenses to compress a solid core. The scientists at Los Alamos considered the uranium gun-type design so fundamentally mechanically simple that testing it was deemed a waste of precious enriched uranium.
Wow. They just built Little Boy, put it on a plane, dropped it untested over a city, and it functioned exactly as the slide rules predicted.
Right. Postol is arguing that if physicists in 1945 could get it right on the first try using chalkboards and analog calculators, Iranian mechanical engineers in 2025, armed with supercomputers and 80 years of unclassified metallurgical literature, can easily replicate it.
It makes sense when you put it that way.
Furthermore, Postol details how they can thoroughly test the mechanical assembly without triggering a nuclear yield anyway.
How do you do that?
You build the entire weapon, the gun tube, the conventional explosives, the initiators. But instead of machining the sphere and plugs out of 90% enriched U-235, you machine them out of depleted uranium-238.
Ah, which has the exact same weight, density, and mechanical properties.
Exactly. You take that dummy bomb into a bunker and you fire it. You use high-speed diagnostics to measure the velocity of the plugs, the symmetry of the impact, and the timing of the beryllium initiator. If the mechanics work flawlessly with depleted uranium, with near absolute certainty that swapping in enriched uranium will produce a 15 kiloton yield.
And this completely bypasses the final geopolitical warning system. Because for decades, global security has relied on the global network of seismic monitors. If a rogue state tests a nuclear weapon underground, the world's seismographs instantly register the unique signature of the blast.
Right. The international community gets a warning, and the geopolitical calculus shifts immediately.
But Postol is saying Iran doesn't need to give the world that warning. The first seismic signature of an Iranian nuclear weapon wouldn't be deep underground in a test facility. It would be an airburst over Tel Aviv.
Yeah.
Which brings us back to the horrifying reality of what actually happens when that 15-kiloton weapon detonates over a modern city.
And Postol drops the political rhetoric entirely here. He just shifts into a clinical, unsparing breakdown of the physics of mass destruction. He assumes an Iranian targeting doctrine aimed at maximizing civilian casualties as a proportional response to the massive casualties inflicted by the initial U.S. and Israeli strike.
So let's walk through the timeline of the detonation, starting at the absolute beginning, the first second.
Okay. When the conventional explosives slam the uranium pieces together and the beryllium initiator floods the core with neutrons, an incomprehensible amount of energy is released into space no bigger than a few cubic meters.
We're talking about events occurring within 100 millionth of a second. The solid uranium metal basically ceases to be solid matter. It becomes a confined, seething plasma of pure energy.
And the temperature inside this localized reaction leaps to tens of millions of degrees.
Just to put that in perspective for you listening, the core of our sun is roughly 15 million degrees Celsius. Postol is describing an event that briefly outshines and outheats a star, hovering a few thousand feet above a city skyline.
It's unfathomable. This unimaginably hot mass instantly emits an intense, blinding burst of X-rays. These X-rays travel outward at the speed of light, but they don't get very far because they violently interact with the surrounding atmosphere. The air itself absorbs the X-rays.
And that absorption transfers the energy, superheating the air immediately surrounding the bomb to roughly 1 million degrees, which creates the initial fireball, expanding rapidly in the first fractions of a second.
Which brings us to the physics of the blast wave. The superheated air within the fireball aggressively expands. Because of thermodynamics, right? Extreme heat causes extreme expansion. But because the temperature differential between the million-degree fireball and the ambient city air is so vast, the expansion happens at supersonic speeds.
Postol uses a really mechanical, visceral analogy here. He says the expanding fireball acts like a fast-moving piston.
Yes. The surrounding cold air literally has no time to smoothly flow out of the way of this expanding sphere. It gets physically shoved and violently compressed by the expanding fireball. The air molecules pile up on themselves, creating an immensely dense, solid wall of high-pressure air that races outward faster than the speed of sound.
This is the shock wave.
This is the shock wave.
By the time we hit the 1-second mark, the fireball has reached its maximum diameter. As it expanded, it cooled significantly, dropping from millions of degrees down to an average temperature of about 8,000 degrees Kelvin.
Which, Postol chillingly notes, is still about 2,000 degrees hotter than the visible surface of the sun.
And this is where we enter that 10-second gap I mentioned at the very start of the deep dive. Because light travels vastly faster than a shock wave of compressed air, there is a temporal disconnect that most people, trained by archival footage and movies, completely fail to realize.
Right. If you are standing in a high-rise building a kilometer, maybe a kilometer and a half away from ground zero, at zero point 0.1 seconds, the flash happens. The intense thermal radiation from a fireball hotter than the sun hits your building at the speed of light.
The front of your building, the paint, the window frames, the plastics instantly begins to vaporize. The thermal heat radiates straight through the glass windows, instantly igniting curtains, rugs, papers on desks, synthetic upholstery. Your entire environment spontaneously erupts into flames.
But the shock wave hasn't hit you yet. You are standing in a room that is actively burning, and you have 10 full seconds of waiting before the physical force of the explosion arrives.
10 seconds is an eternity. Count it out in your head. 1, 2, 3. You are literally watching your office burn. 7, 8, 9.
And then at 10 or 11 seconds, the supersonic piston of compressed air arrives. That wall of pressure envelops the building. It shatters every window instantly, knocks down interior walls, turns office furniture into lethal projectiles, and if the building is close enough to ground zero, it crushes the structural steel entirely.
We have been conditioned to focus entirely on that shockwave. We see the old black and white footage of test houses being blown flat in the Nevada desert, and we think, well, that's the weapon. It blows you up.
Right, but Postol purposefully reorients the listener's fear here. He insists that while the shock wave causes extraordinary localized damage, focusing on the blast wave as the primary cause of mortality in a sprawling modern city is mathematically wrong.
So if the blast doesn't kill you, and in a modern city like Tel Aviv, built heavily with reinforced concrete and structural steel, a lot of buildings a kilometer out will survive the initial shockwave. The environment the blast creates will kill you.
Yeah, this leads us to the most devastating, prolonged phase of the attack.
The ultimate killer, mass fires and firestorms.
Expanding on that 10-second ignition window we talked about, you have a situation where thousands, perhaps tens of thousands of small fires have been ignited across a massive radius by the initial thermal flash.
You have curtains on fire, you have books on fire, and then the blast wave arrives, shattering all the windows. This doesn't blow the fires out. It acts as forced ventilation. It provides unlimited, unrestricted oxygen to the smoldering interiors.
And Postol points out a grim psychological reality here. In a normal apartment fire, the human response is to grab an extinguisher or throw water on the flames. But nobody is trying to put out the fire on the curtains after a nuclear blast.
Of course not. You have just been thrown across the room by a supersonic shockwave. You are deafened, injured, your family is screaming, the structural integrity of your building has failed.
Right. So these thousands of small fires are left completely unchecked to grow and combine.
I have to ask a grounding question here, though. If you're in a modern city built of concrete, glass, and steel, how does it burn like a dry forest? I mean, concrete doesn't catch fire.
The structural skeleton might not burn, but modern cities are packed with incredible fuel loads. The interiors of high-rises are filled with synthetic fabrics, plastics, wood, paper, and vast quantities of industrial chemicals. Furthermore, a firestorm creates its own environmental conditions that basically defy normal thermodynamics. It's not just things burning, it's the atmosphere itself acting as an engine.
Postol explains the macroscopic physics of this mass fire phenomenon. As these tens of thousands of fires grow and merge, they generate an immense, localized amount of hot air, and hot air buoyantly rises.
Imagine a hot air balloon, but the size of several city blocks. The intense concentrated heat from the burning city causes a massive column of air to rapidly rise into the upper atmosphere. And this rapidly rising column creates a vast, powerful low-pressure zone at ground level.
Because nature abhors a vacuum. As that hot air blasts upward, cold air from the periphery of the city is violently sucked inward toward the center of the fire to fill that low-pressure void.
Exactly. This creates macroscopic ground-level winds. We aren't talking about a stiff breeze fueling a campfire here.
Yeah.
Postol estimates these inward rushing winds can easily reach 100 to 200 kilometers per hour.
That is Category 1 to Category 3 hurricane force winds, blowing steadily and violently toward the center of the ignition zone.
Yeah.
To understand the effect of this, think of a blacksmith's forge. When a blacksmith wants to make a fire hot enough to melt steel, they don't just add more coal. They use bellows to force a massive, concentrated stream of oxygen directly into the heart of the flames, turning red coals white hot.
That's a perfect analogy. The rising heat of the initial fires acts as the pulling force, dragging those hurricane winds through the city streets, feeding a self-sustaining, ever-growing inferno. The oxygen feeds the fire creates more heat, the heat rises faster, which sucks in more oxygen. It is a terrifying, inescapable feedback loop.
And Postol anchors this theory in historical data, comparing the effect to the incendiary bombings of Hamburg and Dresden in World War II. He notes that the firestorm in Hamburg wasn't an accident of war. It was heavily studied and intentionally engineered by Allied forces. They dropped incendiary bombs in specific spatial patterns designed to overwhelm the natural fire breaks of the urban topology.
And Postol applies that grim logic to the nuclear scenario, using a truly chilling phrase. He calls it death by careful analysis.
Death by careful analysis.
Wow. He argues that a sophisticated attacker wouldn't just drop all their warheads in one spot. They would mathematically model the urban grid and intentionally space multiple smaller detonations out across the city. By creating multiple, perfectly spaced zones of ignition, they can force these individual fires to merge into a single, citywide firestorm.
One that consumes a vastly larger area than a single, larger megaton weapon could.
Right. They're engineering the atmosphere to maximize the burn area.
The result of this engineered inferno is what he calls the oven effect. Imagine the people who survived the initial blast. When the air raid sirens sounded, they rushed down into deep, subterranean concrete bomb shelters. The heavy concrete walls withstand the shockwave perfectly. They are intact, they feel safe.
But a firestorm isn't a normal fire that sweeps past and moves on. Postol describes a thin wafer of combusting material at ground level, but the temperature within that wafer is staggering. He states that the average air temperature at street level across the entire city will rise above the boiling point of water.
Above 100 degrees Celsius, or 212 degrees Fahrenheit. And this heat isn't a fleeting flash. The firestorm will rage above those underground shelters for 5, 6, 7, maybe 8 uninterrupted hours, burning every single combustible thing in the city until there is simply no fuel left.
And the ground itself absorbs this heat. Concrete and brick are excellent thermal mass materials. They absorb and conduct heat really well. Over those 8 hours, the intense boiling heat from the surface penetrates deep into the earth. The walls of the bomb shelters heat up. The subterranean bunkers literally become ovens, slowly baking anyone trapped inside.
Postol's descriptions of the surface conditions are incredibly bleak. He talks about people trying to flee through the streets. The thermal radiation is so intense the asphalt melts, trapping vehicles and people. The hurricane-force winds don't just feed the main fire, they create localized weather anomalies.
Yeah, because some areas of the city burn hotter than others, it creates extreme differential heating on the ground, which spawns fire tornadoes.
Fire tornado.
He compares them to dust devils you see in the desert, but made entirely of flame, spinning at 200 kilometers per hour. People caught in the open streets are literally incinerated by high-temperature, supersonic winds. He references historical accounts of firefighters in Hamburg who only survived by lying face down in the gutters at the absolute periphery of the fire zone before the full inferno took hold.
Knowing that if they stood up, the superheated winds would sear their lungs and kill them instantly from the inside out.
Yes.
It is an apocalyptic vision. A modern city of glass and steel converted into a blast furnace. But the horror doesn't stop when the fires finally run out of fuel and burn out. For those at the very edges of the firestorm, those who manage to survive the blast, avoid the fire tornadoes, and outrun the heat, there's a third, invisible, and insidious wave of destruction waiting for them.
Right. We must examine the biological and environmental aftermath, radiation and black rain.
Let's jump back to the exact moment of detonation for a second. Alongside the blinding flash of light and the supersonic blast wave, the nuclear reaction releases what is called prompt radiation.
This initial burst consists primarily of high-energy gamma rays and neutrons. Now, unlike the heat and light, which are stopped by solid objects like a heavy concrete building casts a shadow that can protect you from the thermal flash gamma rays, and neutrons penetrate deeply into matter, including human tissue.
And Postol notes a morbid reality about yield size here. With massive, multi-megaton thermonuclear weapons, the blast and fire radii are so gigantic that anyone close enough to receive a lethal dose of prompt radiation is already dead from the explosion or the heat.
Right.
But with smaller, lower-yield weapons, like the 15-kiloton garage bombs he is hypothesizing, there is a deadly sweet spot. At the periphery of the blast, you might survive the shockwave, you might escape the fire, but the invisible gamma rays pass right through your body.
And the biological effects of this exposure are profoundly cruel because the suffering is entirely delayed. A person receives a sublethal prompt dose, They walk out of the rubble. They think they've miraculously survived the worst day in human history.
But the ionizing radiation has fundamentally shattered their cellular machinery on a molecular level.
Right. Postol doesn't just say, oh, people will get sick. He forces the listener to look at the granular biology.
Why does a theoretical physicist dive into such grotesque medical detail?
Because he is systematically trying to strip away the clinical sterilization of nuclear war. He explains that ionizing radiation specifically targets cells in the body that are rapidly dividing, a process called mitosis. The most vulnerable cells in the human body to this kind of radiation are the stem cells located inside your bone marrow.
These are the factories responsible for producing your blood. The radiation physically breaks the double helix DNA inside these stem cells, halting their ability to divide and reproduce.
So for the first few days, the survivor feels relatively fine because they are living on the blood cells already circulating in their system. But blood cells have a short lifespan. Weeks after the attack, as the old cells die off, the irradiated bone marrow fails to replace them. The body simply stops producing platelets, which are the cells that allow blood to coagulate and clot.
But the survivors effectively become severe hemophiliacs. A tiny scratch won't stop bleeding. They begin to hemorrhage internally into their joints and organs.
Simultaneously, their body stops producing white blood cells, which are the immune system's primary defense against bacteria and viruses.
So 2 or 3 weeks after surviving the blast and the firestorm, the survivor begins to bleed internally and minor bacterial exposures. A scrape on the knee, a bit of dust in the lungs, turn into massive, uncontrollable systemic infections.
The death is slow, inevitable, and horrific.
And that biological horror is just from the initial prompt radiation? There's also the massive environmental contamination that follows, specifically a phenomenon known as black rain.
Going back to our macroscopic view of the firestorm, a citywide fire consuming plastics, asphalt, and synthetic chemicals doesn't burn cleanly. It's not the blue flame of a gas stove. It is a massive event of incomplete combustion, producing thousands of tons of thick, heavy carbonaceous soot.
As the intense heat of the firestorm pushes this massive column of soot high into the upper atmosphere, it eventually meets cooler air. The water vapor, naturally present in the atmosphere, needs a physical surface to condense around to form rain droplets. In meteorology, this is called a nucleation point.
Right. Under normal atmospheric conditions, water vapor condenses around tiny, microscopic particles of dust or sea salt. But above a burning city, the water vapor condenses around the billions of soot particles.
And this soot is a highly toxic sponge. It absorbs the chemical byproducts of a burning metropolis, cyanide gas from burning plastics, carbon monoxide, hydrogen sulfide, nitrous oxides, and crucially, it mixes with the radioactive isotopes propelled into the atmosphere by the bomb itself.
So the atmosphere basically wrings itself out over the region, dropping heavy, toxic, highly radioactive black rain back down to Earth, coating everything in a lethal sludge.
What is truly chilling is Postol's strategic analysis of this weather event. He notes that a sophisticated adversary doesn't just launch a missile at random and hope for the best. They employ meteorologists. They intimately understand the predictable patterns of land winds and sea winds in the Mediterranean region.
He suggests an attacker could intentionally, mathematically, time the strike to weaponize the weather. They wait for a specific time of day or a specific season when the sea winds blowing off the Mediterranean are particularly strong. They do this so that the massive radioactive cloud generated by the blast and the firestorm is intentionally blown deep inland, heavily irradiating populated areas far downwind of Tel Aviv.
It is an active, calculated weaponization of the environment to maximize secondary civilian casualties.
Death by careful analysis applied to meteorology.
Exactly. He is painting a picture where every single element, the mechanical spacing of the bombs, the timing of the winds, the yield of the weapons, the topography of the city, is calculated to cause the maximum possible suffering. And again, I have to ask the overarching question, why is he doing this? Why is this highly respected MIT professor delivering an hour-long, unsparing presentation detailing the most grotesque, terrifying ways a human body and a modern city can be mathematically destroyed?
To understand that, we have to look at his ultimate strategic plea, because this visceral horror isn't sadistic, and it isn't for shock value. It is the absolute core of his theory of deterrence. We have to analyze the specific audience he's trying to reach.
Postol states his target demographic very clearly. He wants the political leadership to hear this. But more importantly, he says he wants the Israeli public, the intelligence officers in the Mossad, the commanders of the Air Force, and the ground troops to deeply, intimately understand the specific physical reality.
His goal is remarkably direct and provocative. He wants to induce a level of fear and comprehension so profound that if a political leader orders a preemptive first strike on Iran, the military personnel sitting in the silos, or the pilots sitting in the cockpits, will actively, physically refuse the order.
He is essentially advocating for a military mutiny based entirely on an understanding of physics. He wants the pilot to look at the order and say, "No, sir, I know exactly what happens next. I know they have threshold weapons waiting in the tunnels. I know they have 60% enriched uranium ready to spin. I know they will retaliate. And I am not going to initiate a chain of events that guarantees my own city melting, my own family baking in a subterranean shelter, and radioactive black rain falling on my country."
Postol synthesizes a deeply psychological theory of change here. He argues that peace, or at the very least the avoidance of absolute nuclear annihilation, can only be achieved when populations possess what he calls an intestinal understanding of the consequences of war.
An intestinal understanding, that's a heavy phrase.
It is the antidote to mathematical abstraction, because for decades, military planners, politicians, and the general public have viewed nuclear strikes through a highly abstract, sterilized lens. We look at digital maps with neat little concentric circles drawn on them to represent blast radii. We read sterile think tank statistics about megadeaths and acceptable proportional losses. Postol argues that this abstraction is the direct pathway to catastrophe.
Because if you think of 2 million dead people as just a data point on a spreadsheet, you might convince yourself it's a justifiable strategic necessity to achieve a geopolitical goal.
Right.
But if you are forced to visualize a desiccated corpse in a concrete bunker, or a survivor bleeding to death from radiation-induced hemophilia 3 weeks later, the mathematical abstraction breaks down completely. The physical reality becomes too monstrous to justify the geopolitical goal.
His final message in the interview is a desperate plea for a return to a live and let live attitude in international relations. He insists that recognizing the blunt, untamable reality of mutually assured destruction must force a change in state behavior. He argues that Israel does not have to like the Iranian system of government. They do not have to agree with their policies, but they must respect Iran's right to exist as a sovereign nation to avoid triggering this apocalypse.
He argues that returning to credible diplomacy, the kind of frustrating, slow statecraft that relies on honoring treaties, the kind that has prevented annihilation since the dawn of the nuclear age, is the only viable path forward. The alternative, sleepwalking into a conflict relying on the hubristic assumption that your enemy won't retaliate, leads directly, mathematically, to the firestorms.
It is a doctrine of deterrence achieved not through missile defense systems, but through graphic, unsparing education.
So let's step back and recap the immense journey we've taken in this deep dive. We started with something that sounds incredibly mundane. A few 100 kilograms of crystallized uranium hexafluoride sitting quietly in meter-long canisters.
We traced how political failures, the collapse of diplomatic agreements like the JCPOA, the demand for further leverage, and the breakdown of international trust can act as the catalyst that heats those canisters, turning that dormant crystal into a hot gas.
We followed that gas into the supersonic cascades of centrifuges, watching it sprint from 60% to 90% enrichment in a matter of weeks, crossing the invisible, terrifying line of a threshold state. We explored the closet-sized chemical labs that use cyclone separators and thermite reactions to turn that gas into green dust, and then into solid metal ingots.
We examined the terrifying brute force simplicity of the gun-type atomic bomb, relying on beryllium initiators and historical Manhattan Project data to prove that a weapon can be fundamentally reliable without ever triggering a seismic warning test.
And then we confronted the nightmare reality of its use over a modern city. We moved from the million-degree flash of X-rays to the supersonic piston of the shockwave. We stood in the agonizing 10-second gap as an entire city catches fire before the physical blast even arrives.
We mapped the thermodynamics of a mass firestorm, the Category 3 hurricane winds pulling oxygen into the center, the thermal conductivity of concrete baking subterranean shelters into ovens over 8 long hours, and the apocalyptic localized weather of fire tornadoes.
We faced the invisible aftermath, diving into the cellular biology of prompt radiation that shatters DNA and destroys the body's ability to heal itself weeks later. We looked at the meteorology of black rain, thick with soot and toxins, intentionally blown inland to poison whatever the fire didn't touch.
And we ended on Theodore Postol's desperate strategic gamble. The hope that, by forcing us to look at the unvarnished, gruesome reality of this physics, military leaders and civilians alike will find the moral and intestinal fortitude to refuse the path of preemptive war and demand a return to diplomatic sanity.
Which leaves us with a provocative thought to mull over. something that builds on everything we've discussed today regarding the shifting landscape of global security.
If the technological barrier to building a nuclear weapon has truly shrunk to a closet-sized space, a few off-the-shelf industrial chemicals, and a few weeks of centrifuge spinning, well,
Does traditional nuclear nonproliferation even work anymore? I mean, think about it. For 70 years, the global security apparatus has focused entirely on controlling the ability to build a bomb. We tracked massive shipments of specialized steel. We monitored seismic activity for underground tests. We relied on the immense difficulty of the engineering and the vast footprint of the infrastructure to keep us safe.
but if a threshold state can quietly sidestep all those hurdles in subterranean tunnels, if the spring is already wound to the breaking point requiring only a spark of political will to snap, then controlling the ability is no longer enough. The physical barrier is gone.
Do we now live in an era where our entire survival depends not on restricting a nation's ability to build these weapons, but entirely on our capacity to remove their desire to use them? Can modern diplomacy evolve to handle a world where the power of the sun can be cobbled together in a tunnel in less than a month?
That is the immense existential question preceding it. Postal's scenario leaves hanging over us.
When you look back at that illusion of control we sometimes cling to, the idea of clean, surgical, binary, modern warfare, it really does seem like a comforting fiction we tell ourselves to avoid looking at the fire. We want to thank you for joining us on this intense, highly technical, and deeply unsettling deep dive. It's not easy material to confront, but understanding the raw mechanics of these threats is the absolute first step in demanding a world where they remain strictly hypothetical.